Don't echo. Don't echo. Don't echo. Don't echo. Beginning of the video. It's already recording. Yay! It's not echoing. Alright, that's the problem that happens a lot. So we're finishing 1.5. Yesterday we solved absolute value equations, and you all remember we had to split them into the two parts, the positive one and the negative one. Okay, same thing today, but now we've got inequalities, and since there's that inequality symbol, it's a little more complicated, but we'll be okay. That wrapper's really loud. Okay. Now, we have our inequalities that are going to have greater than and our inequalities that have less than. Whether they have greater than or equal to or just greater than, you're going to follow what we write here. If it has this, which is less than or equal to, or just less than, you're going to follow what we do down here. Okay? I didn't want to have to write it 4 times when it's really just the same thing. So, the first thing to realize is when you have an inequality, that when the absolute value is by itself and it's a greater than, you treat it as a or compound inequality. Y'all remember that we did them differently the other day when we graphed?
Yes.
Whether it was or and?
Yep.
We're doing the same thing. So if it's greater than, it's or. If it's less than, we treat it as an and. So which one did we want only the overlap of the two graphs? Or it was and, yes. Okay, this one is just the overlap or takes everything that at any point has a graph on it. Okay, this is overlap, this is not, or overlap plus everything else. Oh, I turned the flashlight on this. It shined in my eye, it was loud, or bright. Alright, now, when it is or, here's the process you follow. Remember how we just, yesterday we split it into 2, so we're going to do that. And the first one, we just took it out of absolute value and wrote it how it was. That's what we're doing with or for the first one, actually for and as well. So the first one looks like this. And then, whoa, sorry. And then it'll say or, that's supposed to be an R. Now, take the X again, and we're going to make the K negative, like we would have yesterday. But, guess what we're going to do with the symbol? Flip it. Alright, so just take the symbol, flip it, make whatever was on the other side, put negative in front of it. Don't forget that the entire thing has to be negative, not just the first term. Alright, now and, similar, actually very similar, but we start out with the less than. Okay, so the first one's going to be X less than or equal to K, then we say and what do you think the next part's going to be? X is greater than or equal to negative K. We good?
Yeah.
All right. Now one not tricky thing, but just what it is that the and compound inequalities, we may have talked about this the other day. You can write it as one phrase, so it would look like this, that negative K is less than or equal to X is less than or equal to positive K. This means the same thing as this. Alright? Okay. So, if you look at it, they have the same thing written down. Okay, look at, I need to figure out how to block this out. I don't know how to do that. Okay, so look at just this part. What does that match? The first inequality, right? Okay, so that goes with that. Now, let's undo that. Let's look at this. Okay, that one, though it looks a little different, actually does in fact match this. It just kind of got reversed backwards. So we have X, there's our X, is greater than, we're reading it backwards down here. X is greater than negative k. X is greater than negative k. Okay. So if the book gives you one of these where it's all together, you can just split it into the two parts. All right, the X just goes with both sides. All right. That'll make more sense when we look at it on the number line, which we'll do on our second example. So for the first example, remember with absolute value, our first question is absolute value by itself? So is it? Yes, so we don't have to move anything. So based on that sign, is it an or an and? Or is correct. Or. What is our first inequality going to be? 3x plus 6, and then do we keep the sign? Yes, and then do we keep the 12 how it is? Yes. Now for the second one, 3x plus 6 stays the same, but what happens to the symbol? It flips. What happens to the 12? It's negative. This stylus is awesome. This stylus is awesome. Okay, let's solve it. So what should we move first? The 6. We're going to subtract 6 from both sides. So we get 3x is greater than or equal to 6. Now what? Very good. Divide by 3. X is greater than or equal to 2. Are you cold, Holden? Sorry. Y'all are cold too? Okay. Let's deal with the other one. The 6 again goes first. So we subtract it to the other side. This time 3x is less than negative 18. Divide by 3, divide by 3. Do we need to flip the sign? We just divided. Do we need to flip it? Oh, no. Why not? Because it's not negative. I tricked you. Or. Remember that it's or. So that is the first part of our answer. The other part is our graph. On our graph, y'all know that y'all have noticed probably that I'm not requiring you to write out all the numbers. Write out the two that you need and then put a number in between them just so we have a little reference. I usually like to put 0 and actually make it in the right spot. 0 is not in the middle of negative 6 and 2. Put it in the right spot. Now, we're going to put these off the graph first just to kind of see what we have, and then we'll put them on the graph. So at 2, is it open or closed? Closed. Right or left? Right, because it's greater than. Okay, at negative 6, open or closed? Right or left? Left. Okay, now let's think about it. We're doing or. So it said for or compound inequalities, we need any values that satisfy at least one of the inequalities. Okay, so all of these satisfy one, all of these satisfy one, so we're going to put both on our graph. Okay, so we'll have everything less than negative 6 and everything bigger than 2. Make sure you have your arrows so we know it goes on forever. Some people did the whole graph it above to see, but they never actually put it on the line, which meant a couple points off. Okay, so make sure you put your graph on the line. Ready to keep going? Okay. First question, is absolute value by itself? No, we need to move some things. So we need to move the 3 and the negative 9. Which one first? The 9. Very good. So we're going to add 9. So 3 greater or absolute value 2x plus 6 is less than 24. Now what was the 3? Divide. Again, we don't have to flip the sign because it's positive. All right, now looking at it. Is it going to be or and? And, very good, it's less than, so it's and. Okay, you can maybe remember those. If it's greater than, greater has R's in it, so or, because or has R's. Less than doesn't have an R in it, and neither does and. That's just my, off the top of my head, maybe how to remember it. Okay, so first one is going to be 2x plus 6 less than 8. We just leave it how it is, except without absolute value. Then what's the other one going to be? The 8's going to be negative. What about the symbol? Flip it. So now we've got greater than. All right. What should we move first? The 6 to both sides. So we get 2x is less than 2. Then we divide by 2, divide by 2. X is less than 1. And the other side, subtract 6 from both. 2x is greater than negative 14. Divide by 2. Divide by 2. X is greater than negative 7. So there's first part of our answer. Graph is the other part. Ready to graph? So we need our negative 7 down here. 1 will be here, so that puts 0 like right there. I'm going to graph it off the graph first, and then we'll put it on. Okay, so let's see. At 1, open or closed? Open, right or left? Left. Okay, at negative 7, open or closed? Right or left? Right. It's and. What are we looking for? The overlap. So we just need this part. It does not include negative 7. So we're open there. It does not include 1. So we're open there. And then we color in between. Now remember that we can write the and inequalities as one thing, so x is in the middle, the less than signs are on both sides, negative number down there, positive one there. It may help you to look at this now. So x is everything between negative 7 and 1. So that matches the graph, right? Negative 7, 1, x is everything in between. Okay, so something like that may help you understand this more. Are we good? Any questions? No? All right. Finish your homework then.